Supposed to graph this function. Here we have our x and y axis. Y is vertical, x is horizontal. The boundary here is just a line. Y-intercept is 9, and the slope is -4. Since this boundary says greater than, it should be dashed, shouldn't be solid. Once again, this y-intercept here is 9. And it says y is greater than, so it's shaded above. Well, the other thing to do here is find the x-intercept. To do so, put 0 in for y and get x by itself. You'll find the x-intercept is 9/4. That's it for number 1. Number 2, we're supposed to also graph. X-axis is horizontal, y-axis is vertical. Y is less than x squared minus 5. X squared is a parabola. The minus 5 translates it down 5. So its location is going to be 0 and -5. That's where the vertex is. It says y is less than, so it's shaded below. The only thing left to do is find the x-intercepts. To find x-intercepts, simply put 0 in for y into the boundary and get x by itself. If you add 5 to both sides, and then square root both sides, you get the x-intercepts are plus and minus 5. So one x-intercept is here, and it's positive square root of 5. The other x-intercept's over here, and it's negative square root of 5. That's it. Number 3, you're supposed to graph your x and y axis. It's important, I think, to get y by itself before you start to graph these problems. That way you know how it relates to the parent. The parent equation for this is the absolute value function. This plus 2 moves it to the left, and this minus 5 moves it down. So we go left 2 and down 5, might be maybe at this location. And then it is the absolute value function. This right side here has a slope of 1, and the left side has a slope of -1. It says y is, reading with the y first, so reading from right to left, y is less than, it says. Less than is shaded below. Find x-intercepts once again. Really the most difficult part of these problems is finding the x-intercepts. To find the x-intercepts, put 0 in for y into the boundary. When solving an absolute value problem, get what's inside the absolute value by itself. Then you make 2 separate problems. One where you simply remove the absolute value, or one where you remove the absolute value and you make the opposite side of the equation that didn't have the absolute value, change its sign. So that would be x plus 2 is equal to -5. Solving each of these, if we solve the first one, we get x is 2. So this x-intercept here might be 2. The other one, if we subtract 2 from both sides, a -5 and a -2 is a -7. Let me rewrite this -5 for a third time. So those are the x-intercepts. And that is the graph for number 3. Number 4, also an absolute value function. The plus 3 moves it to the left. The minus 2 moves it down. So let's say that we're at -3, -2. It says y is greater than, so it's a dashed boundary. It says y is greater than, so it's shaded above. Find the x-intercepts. To do so, put 0 in for y into the boundary. Get the absolute value by itself. Make two separate equations. One where you remove the absolute value bars. The other where you remove the absolute value bars. This is an OR problem when you have the absolute value and equal sign. And you also take the side that didn't have an absolute value and you make it negative. Solving each of these, we're going to get x-intercept of -1 and -5. That's it for number 4. Number 5, once again we have our x and y axis. This is a parabola. The -4 translates it to the right 4. So the boundary looks a little something like this. It says y is greater than, so it's shaded above. To find the y-intercept, we already have the x-intercept. Put 0 in for x into the boundary. Simplify it. 0 minus 4 is -4. -4 squared is 16 positive. That's it for number 5. Number 6, this is the inverse of y equals x cubed. Y equals x cubed looks like this. So the inverse of this is going to look like this. A function and its inverse are reflected about the line y equals x. And then the plus 8 here moves it to the left 8, and the minus 8 moves it down 8. So we translate left and down 8. Let's say that that's here. Nothing else about this curve is different. So it's coming up, and then it's coming to the right, like so. It says y is less than. It should be dashed, not solid. Should be dashed. It says y is less than, so you shade below. X and y intercepts. Find the x-intercept. Put 0 in for y into the boundary, and you get x by itself. Then add 8 to both sides. I'm going to cube both sides. 8 cubed is 512. I'm going to subtract 8 from both sides. And get the x-intercept, assuming that I subtracted, cubed correctly, is 504. To find the y-intercept, I put 0 into x into the boundary. 8 plus 0 is 8. The cubed root of 8 is 2. 2 times 2 times 2 is 8. 2 minus 8 is negative 6. So my y-intercept, your y-intercept is 0, negative 6. And that's number 6. The directions here for 7 are to solve the inequality, not to graph it. So when you're solving in an absolute value problem, first get the absolute value by itself, which it already is. Then you make two separate problems. Depending on if it's less than, if it's less than, it's an and problem. If it's a greater, it's an or problem. It says less than. So we have 2x plus 7 equals 0, pardon me, it's less than 0. And to get your other inequality, remove the absolute value bars, make your inequality change direction, and change the sign of 0 so it's a negative 0. Of course, a negative 0 is just 0. Solving each of these, when solving an inequality, you solve it the same way you solve an equation, with one exception. If you multiply both sides by a negative number, you should change the inequality symbol to face the other direction. That doesn't happen in the way that I'm solving this. So I got these two answers. X is less than negative 7 over 2, and x is greater than negative 7 over 2. Put that on a number line. The only solution that I have here, number-wise, is 7 over 2. Above this, x is less than 7 halves, goes to the left. X is greater than 7 halves, goes to the right. They're open circles because they don't include those. For an and problem, which is what this is, it's where those graphs overlap. They don't overlap. So your solution is the empty set. There is no solution for that. Number 8, absolute value. Once again, when you're solving this, get the absolute value by itself. It's already by itself. Make two separate inequalities. One, where you just remove the absolute value bar. The other, we remove the absolute value bars, change the inequality to face the other direction, and change the sign of the side that didn't have an absolute value. Since this is read with the absolute value first, the absolute value is greater, this is an or problem. Solving each of these. On the left, if you subtract x from both sides, you get 0 is greater than 0. If you have no variables left, you need to ask yourself, is that a true statement or a false statement? 0 is greater than 0. That's definitely a false statement. Solving the other inequality, if I were to add x to both sides, I would get 2x is less than 0. Divide both sides by 2, I get x is less than 0. So my two solutions are false, which means no solution, and x is less than 0. On a number line, I put any numbers I get from my solutions. 0 is the only number I got. No solution means I put nothing on here. And x is less than 0. Put an open circle above 0, and I go to the left. If it's an or problem, your answer is a combination of these two answers. So one answer says nothing. The other one said x is less than 0. So the combination, putting this all together, we're saying that the set of all x's is such that x is less than 0. We're also saying in interval notation that we start all the way to the left, which is negative infinity, and it goes until it gets to 0, and then it stops. Use parentheses because we are not including the number 0. If we were to include it, then it would be a bracket. For number 9 here, we would get the absolute value by itself before you split this up. you get two separate inequalities. One where you have just remove the absolute value bars. The other where you take off the absolute value bars, change the direction of the inequality symbol, and make the x negative. The original with the absolute value first is greater, so this is an OR problem. Solving this, first inequality, if you subtract x from both sides, you get 2 is greater than or equal to 0. It's a true statement, therefore the solution is all real numbers. Solving the other inequality, if you subtract x from both sides, you get 2 is less than or equal to negative 2x. If you divide both sides by negative 2, we're dividing both sides by negative number. Inequality is going to change direction anytime that happens. So we get all real numbers, or x is less than or equal to negative 1. When you combine those on a number line, all real numbers is everything. X is less than or equal to negative 1 is a closed circle at negative 1, and less than goes to the left. An OR problem is the combination of those answers. So in set notation, we could simply say all real numbers. You could also say the set of all x's such that x is an element of the real numbers. That works as well. Interval notation, you would say that we're going from negative infinity to infinity. Number 10, you're supposed to put this in your calculator. Ask your calculator to shade it accordingly. If you do that, you just put into y1 the equation that you see here. Then to get it to shade accordingly, I'm sure there's more than one way to do it. If you move your cursor all the way to the left of the y equals, once you get it there, keep hitting enter until you get this symbol. This symbol means shade above, which is not what we want to do. We want to shade below. Forgive me. Keep hitting that button until you get this symbol. This symbol means that you're shading below. So you'll see that it looks something like this. To my knowledge, your calculator won't do the boundary dashed, so you have to use your noodle for that. If you ask your calculator for the intercepts, the X intercepts, it should tell you that one of these X intercepts is 1, and the other is negative 3. If you ask it for the minimum, by doing second calculate minimum, you should get negative 1, negative 4. That does not show up very well. Negative 1, negative 4. If you ask for the y-intercept, you should get negative 3. That's it for 10. Number 11, if you graph this with your calculator, find the absolute value function. It's ABS. It's under the math button on your calculator. This plus 2 would translate it up to, so your graph would look something like this. Y is less than, so it's shaded below. The vertex is 0, negative 2. And there's no x-intercepts, and that's the y-intercept. So that's it for number 11. Number 12 says to solve the system of inequalities by graphing. So here we have our x and y axis. If we graph each of these, I'll call this one my red function and this one my blue function. The red function, because of this 2 here, it's stretched vertically by 2. This 2 moves it to the right, and this 5 moves it down. So if I go right 2 and down 5, that puts me here. It's 2, -5. And in the graph, the parabola looks something like this. It says y is greater than, so it's shaded above. For the other one, the blue one, this negative reflects it over the x-axis, so now it's facing down instead of up. And this -2 translates it to the right 2. So your curve looks a little something like this. That should be dashed. Pardon me for not dashing it. And it is shaded below. Should label that vertex. Vertex was 2, 0. So our answer is the combination of those. It's where they overlap. It's where the blue and the red overlap. Overlapping in this area, and its boundary, once again, is dashed. So our answer is in here. That is 12. 13. Bark makes customized picture frames. A customer came into her shop and requested that she make a square frame that uses 1.5 inch wide wood. So here's the frame. The thickness of this frame is 1.5 inches all the way around. And she wants it sized so that the area of the family crest, so that means the family crest is going to be in here someplace. This is my personal family crest, because I am a lover, not a fighter. Should be at most 2/3 of the total area of the picture in the frame. That's a lot of information that, quite frankly, makes my head bleed. Write an inequality that describes the possible lengths of one side of the frame. Let me start with that. I'm going to say x is the size of the frame. X equals frame size. If that is x, that makes this one here x minus 3. And it makes this side here also x minus 3. Let me explain. If this whole thing from here to here is x, and you're getting rid of 1.5 and 1.5 to get what's in here, it means you're subtracting 3, because 1.5 and 1.5 is 3. So that makes that x minus 3. I'm just getting rid of this because it takes up too much room. So that means that the area of the frame is x times x, which is x squared. The area of the crest, well, that's going to be x minus 3 times x minus 3, which is x minus 3 squared. I should say what F and C stand for. It's called defining your variables. F is the frame. And picture. C is just the picture, or the crest. Always define your variables. So, we got the area of the frame, the area of the crest. Let's get to the hard part, what I think is the hard part. It says the family crest was at most, so the area of the crest was at most less than or equal to 2/3 the total area of the picture and frame So there's your equation. Area of the crest was at most less than or equal to 2/3 the area of the picture and frame, which I have F for frame. Once you get to this point, it's pretty simple. A sub C is the difference of x and 3 squared. A sub F is x squared. If you multiply this out on the left FOIL or box method, you get x squared minus 6x plus 9 less than or equal to 2/3 x squared. And if you get all the terms on the same side by subtracting 2/3 x squared from both sides, you get 1/3 x squared minus 6x plus 9 is less than or equal to 0. Question. Write an inequality to describe the possible lengths of one side of the frame. And this is our answer. 14. The 1992 presidential campaign had 3 prominent candidates. In April, a TV news program stated that Ross Perot, here's an interesting fact. I know that Perot had to have a native land of France, because it ends in a T, but you don't pronounce it. Many words in French that end in consonants, you don't pronounce them, except for C, R, F, and L. You can remember it's C, R, F, and L, because if you put those together, you get the word careful. That one's for free. Ross was favored by 35% of the American voters, with a marginal error of 3.3%. Write an inequality to describe the range of percents of American voters who favored Ross Perot at that time. This problem can be done in the simplest way that you can imagine. News says 35% of people like Ross, but they said we could be off by as much as 3.3%. So he could have 3.3% more votes, or he could have 3.3% less votes. If you add 3.3 to this, you get 38.5%. If you subtract 3.3 from this, you get 31.7%. So write an inequality, 3.17% less than or equal to x, which is less than or equal to 38.5%. Forgive me, I couldn't read my own handwriting. It's 38.3%. So this over here, 38.3.